Welcome to Uma's Classroom for Math and Science videos. This video is on the topic Law of Conservation of Mass, that is a part of Laws of Chemical Combination from High School Chemistry and AP Chemistry curriculum. There are certain rules followed by all atoms while combining to form a compound. Those rules are collectively known as Laws of Chemical Combinations. And they are: the first one, law of conservation of mass; second one, law of constant composition or law of definite proportion; third one, law of multiple proportion; and the fourth one, law of reciprocal proportion. I already mentioned in this video we will learn about the law of conservation of mass. Law of conservation of mass is the basis of stoichiometry. Stoichiometry refers to the relation between the relative quantities of substances taking part in a reaction to form a compound. So basically a ratio of whole numbers. The law of conservation of mass was proposed by Antony Lavoisier in 1789. The law states that matter can neither be created nor be destroyed. In other way, the total mass of the closed system before the physical transformation or chemical reaction would exactly be equal to the total mass of the system after the desired change takes place. The law was mainly proposed based on the observation of chemical changes, but it comes true for physical changes also. Lavoisier heated mercuric oxide, HgO, and observed that the amount of chemicals mass decreased was equal to the mass of oxygen gas released in the chemical reaction. Here is another example where the law of conservation of mass holds good. If a small piece of carbon is burnt in presence of air, of course it will combine with oxygen in a closed container, then the mass of carbon plus the mass of oxygen is going to be exactly equal to the mass of carbon dioxide. And closed container is very essential here, otherwise the reactant or product, if any gaseous substance is present, that can escape easily from the system. It is advised to carry out all the experiments inside the closed container to check the law of conservation of mass holds good or not. Here is an example to show that law of conservation of mass holds good for physical change. We can see here is a glass filled with suppose 200 gram ice cubes where water is present in its solid form, and after the physical change is taking place, that means when the ice is melted into water, if the total mass of the glass and water is taken, we will find the glass filled with 200 gram of liquid water. The total mass of ice cube and the glass is going to be exactly equal to the total mass of the water and the glass. So here mass of glass plus mass of ice cubes would be equal to the mass of glass plus mass of water. Here is the example to see law of conservation of mass holds good for chemical changes. So according to the rule, total mass will remain same regardless of the way of the change of substance in a closed system. Here in the left hand side of this balanced equation for this reaction, we can see calcium chloride and sodium sulfate. These two are the reactants and they are allowed to react with each other. Finally, we are getting calcium sulfate and sodium chloride as the products of this reaction. We can see a balanced reaction over here. Now let's check whether the law of conservation of mass holds good for this reaction or not. To check this part, we need to find out the molecular mass of all the reactants as well as all the products. Then we will add the masses of reactants to check whether it is exactly equal to the masses of the products or not. So let's start with the first one, this one, for calcium chloride. We know that for calcium, the atomic mass is 40 plus. We can see two chlorine atoms are present, so it is going to be 2 times 35.5, which is equal to 40 plus 71. 35.5 is the atomic mass of a single chlorine, equals to 111. Now, for this one, sodium sulfate. Here we can see two sodium atoms are present. So, atomic mass for a single sodium atom is 23. So, this is going to be 2 times 23 plus for sulfur, the atomic mass is 32 for a single sulfur atom, and for oxygen, a single oxygen atom is having its atomic mass 16, and we can see 4 atoms are present, 4 oxygen atoms, so the 16 should be multiplied by 4. Let's finish this calculation. This is 46 plus 32 plus 64 gives us 142. Now, so this one plus this one, 111 plus 142. This is the total mass of the reactants. So let's see, this is coming 253. Now we will check for the product part. The first one is calcium sulfate, CaSO4. For calcium, we know this is 40 plus sulfur, this is 32 plus, we already know that the atomic mass of oxygen is 16, and here 4 atoms are present, so 4 times 16, it is now going to be 40 plus 32 plus 64 equals 136. Similarly, if we try to find out for sodium chloride, this is going to be equal to, sodium is 23 plus chlorine 35.5. As I am using balanced equation here, so 2 molecules of sodium chlorides are present. So the entire quantity has to be multiplied with 2. This is giving me 2 times 58.5 equals to 117. Now let's check the total mass of the right hand side, means product side. 136 gram plus 117 gram equals which is exactly equal to the reactant side. Here I would like to make sure I have put the correct signs and units as required. Hope you are enjoying this video. So keep on watching math and science videos from Uma's classroom. Don't forget to subscribe, share, like and comment. There is another example to show that the law of conservation of mass holds good for chemical changes. From the picture, it is clear to all of us, this is the reaction of photosynthesis. So the equation for this chemical reaction of photosynthesis is 6CO2 carbon dioxide plus 6 water. Giving us C6H12O6, that is glucose, plus 6 oxygen. This is the balanced equation for the photosynthesis reaction. From the picture, we can see the amount of carbon dioxide and the amount of water required for the reaction to take place is given here. So I will just use the values from the picture. According to the picture, carbon dioxide is 264 gram plus water is 108 gram. So if we add them, we are getting a value of 372 gram. So this is for the reactant side. Let's check for the product side. From the picture, we can see for the product, sugar or glucose, this is 180 plus. For oxygen, it is 192 gram. Let's check the total mass. This is also coming as 372 gram. So, total mass of the reactants are exactly equal to the total mass of the products over here. That means the law of conservation of mass is valid for this reaction too. We will exactly see how to solve the problems based on law of conservation of mass. For our convenience, this law is restated over here, and we already know these 2 points, this one and this one. So we are directly coming to the example. If 216 gram of mercury 2 sulfide are used and 200 gram of mercury are made, how many grams of sulfur must have been made? As the total amount of reactants are given here and partially the amount of products that is also given here, so I will simply apply the law of conservation of mass like this. In a chemical reaction, mass of the reactants must be equal to the mass of the products. So, according to this statement, mass of the reactant is this one, 216. So the total mass of the products should exactly be equal to 216. According to the problem, mass of mercury, that is one of the products, is already provided as 200 grams. So let's consider the mass of the other product, that is sulfur, is as x gram. Simply I will apply the equation that 216 is equals to 200 plus x. And now if we solve this simple equation as it is shown over here, we are getting the amount of sulfur made is 16 gram. We have another example here which states that 18.02 gram of water are separated by electrolysis into its component gases. If 16 gram of oxygen gas are obtained, what mass of hydrogen gas must be obtained? So here I will stick to the law of conservation of mass regardless the point the equation is balanced or not. Though here I have written the balanced equation for this particular chemical reaction, but according to the question, the mass of water undergoing electrolysis was 18.02 gram and the amount of oxygen gas produced, it was 16 gram. We are supposed to find out the mass of hydrogen. So just like before, let's consider the mass of hydrogen as x gram. And according to the law of conservation of mass for this particular situation, it is going to be 18.02 equals to x plus 16. And solving this simple equation, we are getting x equals 18.02 minus 16 equals 2.02 gram. And This is the final answer. The law of conservation of mass is the basis of stoichiometry, so it is very useful. Despite of that, it has some limitations. In case of nuclear fusion reaction, the law of conservation of mass is not obeyed, as certain portion of mass is converted into energy. So, afterwards Einstein modified it and proposed that the total mass and energy in a system remain constant. And this modified law is known as the law of conservation of mass and energy. So this was all about our today's discussion. Thank you so much.